quite a long one, and it's going to be a little bit painful in your brain, because we're going to look at a very special kind of thing, a very special kind of number, and it's called a complex number. Now, this type of thing is not the kind of thing that you are going to notice or see in your everyday life. You are never going to walk down the street and see a lamppost that's 4 complex numbers tall, right, or anything. That's not the way that is. This is pure math, right? It does actually get used in certain branches of sciences. It get used a little bit in electronics. These things called complex numbers. You don't quite know what they are yet, but they get used in electronics a little bit. And they do get used for some reason in animation. So if you're into either of those two things, you might actually get to use them in a practical way. So I don't want you to think about what am I going to do with these things, because that's probably the wrong way to look at them. I want you to think of it as a kind of interesting, unusual mathematical thing. Because what we're doing here is we're just opening your mind to seeing the world in different ways. So if I went and said to you a very simple question, the answer is not that simple. What is a number? What is a number? What makes something a number? I mean, you can give me examples, right? 4 is a number, right? Is 0.7 a number? Yeah, it's a decimal number, but it's a number, right? Is 3/4 a number? Sure, it's just a fraction number, right? But what makes a number in mathematics?
Its value.
Right, it has some kind of value to it, right? Whatever that means. So you could measure something and it would be 2.5 inches long, right? Or you could weigh something and it's 1.5 kilograms, right? Or you could read the temperature and it's -4 degrees, right? Right? It has some kind of value attached to it. But in mathematics, a number is something a little bit bigger than that. A number is an object, a thing, if you like, in which you can do the following. So a number or numbers are objects in which you can do the following. You can add them together. And I guess I should put and subtract, because that's really similar calculation. You can multiply them. And you can divide them. So if you've got a group of things, a group of objects, and these objects can be added within themselves and get an answer that's one of the objects, and you can multiply 2 of them and the answer is one of the objects, or you can divide 2 of them and one of them the object, you've essentially got a number. There are lots of different examples of numbers. In fact, I'm going to just give you a list to give you an idea of what they are. There's a group of numbers called the natural numbers. They were actually pretty much the first numbers that any society, no matter how primitive they are, would work with. And natural numbers are those guys there. And I bet you if you went back to the caveman days and you could communicate with that person, wouldn't he have to know things like, I've got 3 kids? Because he'd have to know if he lost one, right? Or I've got 10 sheep, right? He has to be able to count, right? It's a practical thing. But would you agree that if you were a caveman, you only really need to know you've got 3 kids and 10 sheep? Would you agree for a caveman, 3.5 is probably something that wouldn't make sense to him? How can you have half a kid? How can you have half a goat, right? They only needed those numbers, and that was that is the most common number system. And the Chinese have natural numbers, Ugandans have natural numbers, Scottish people have natural numbers. So they might not call them 1, 2, 3. And today in the world we use the same symbols because we've all got together. But you know, in the past we didn't even used to use the same symbols. If you were a Roman, you would have called it 1, 2, 3, and 4. You know, the Romans did that. If you were from the Mayans in South America, you do 1, 2, 3, 4, and then they did a line for 5. So I guess I should put 5 in. The next number system that came, so you can know a lot of history here. The next number system that developed was called the whole numbers. And the whole numbers have only one difference. They have a 0. You know, the Romans didn't know what 0 was. They never had an idea or a concept of 0 as far as we could tell. If you think about it in a way, who would want to say, I've got 0 soldiers, right? I've got 0 sheep. I mean, what would the use of 0 be to these people, right? They didn't need them. But we needed them. And the reason why we need 0 is that it allows us to have very big numbers, because we can use what's called place value. And this is pretty much universal now. And it was, well, a couple of early cultures have claimed responsibility. But I think India gets the prize. Place value means you can write down 470. And that 0 means 0 units, 7 tens, and 400s, right? It's a very convenient way of doing big numbers. If you try to look at what a Roman version of 470 looked like, you would not want to do it. You know, the Romans are full of MC, X, V, VIs and all that kind of. Can you imagine how bad that would be? Can you imagine the Mayans trying to do it? I mean, it would be horrendous. But it's very easy for us. So whole numbers. Then we went and we did rational numbers. Although they kind of worked, they were kind of existing or coexisting. Rational numbers are basically fractions. So all of these guys count as rational numbers. Do you know 4 can be written as 4 over 1? So technically you could think of it as like a fraction. So they're the guys with things like 3/4 and a half, right? And 17 3/4, right? That's fractions. Why would you need fractions in a society? Can you imagine a point in life where you might need to know half of something? Any ideas? Why would you need to know half of something or 3/4 of something or some fraction? Say again?
For building?
Yeah, you might. You might want to take a building and you know, make another building half the size, right? So you have to half everything to get the dimensions. Can you imagine when someone died, you had to share out, you know, inheritance amongst 2 sons or something? When you have to have some way of splitting into even parts. Rational numbers came. We're almost finished with these guys. There are a few more. We've got 4. 4. Integers. They are numbers like -3, -2, 1, 0, but it's also got fractions, and it also includes decimals. Positive and negative. So integers are basically rational numbers, but with negatives added. Integers, i.e. negative numbers, are quite new in the number system. See, 400 years, well, maybe 500 years ago, if you went and said -2 to somebody, they would have no idea of what negative meant. Do you know where why they needed negatives? When the banking system started taking over, right? When societies had banks and banks would, give you money and you'd have to pay it back, right? Or you gave them money and they reinvested it. And wouldn't you have to have positive or negative numbers? Because you want to know, John owes me money, right? Because I loaned him it. But Peter, he's got money invested in my bank, right? You had to distinguish between the two. Do you know they used to do it in red and black ink? You ever heard the saying he's in the black or he's in the red? And you wondered what that was about? They used colour scheme, but colours were kind of notoriously... Can you imagine a red that might fade into a black if you weren't careful? And then that would be very hard to argue. Hey, how much money do you owe me or do I owe you? So they used negative symbols. So -10 would be, I've got an overdraft in the bank and I owe them $10, right? And +100 would mean I am good. And then we get to what was believed to be the last number system, and they were called real numbers. And you might think, well, what's real numbers? Haven't we covered everything? Well, real numbers are integers, right? So they have negative numbers, they have zero, they have decimals, they have fractions, they have all those things. And then they have radicals, for example. Isn't the square root of 2 not really an exact number? You can't write it down as an exact decimal, right? If you put it in the calculator, it goes on forever. Those guys there, those numbers that can't be written as a fractional, are called irrational. And real numbers are basically every number you could imagine that would fit on a number line. So if you imagine a number, oops, that might be roughly where the square root of 2 is. That's where a half is. That's where -2/3 is. Can you see that everything can be thought of as a distance on a number line? And we call them real numbers. Well, that's the history of it. So what in heck is these complex numbers? Because I haven't mentioned them. A mathematician somewhere had a puzzle that he wanted to solve. And it was that puzzle. And he was thinking, I wonder what the solution is. Well, you know what to do. You would take the square root of both sides. And let's say we just took the positive answer. There is no real number that's a square root of -1, because you can't get the square root of -1. Agreed? You can't get a normal number, or a real number, that when you multiply it by itself, you get -1. Try the possibilities. What could you do? Well, what about -1? Would that work? Well, not really, because isn't -1 times -1 +1? That didn't work. Is there some weird fraction like -3/4 times -3? No, because if you take any number that's positive and you multiply it by itself, which is another positive number, isn't the answer going to be positive? And if you take any negative number, no matter what it is, and you multiply it by another negative number, isn't the answer still going to be positive? Do you see that there is no way to get -1? Right? It doesn't exist as a real number. And for quite a long time, mathematicians just thought, well, there's no solution. Well, technically speaking, they should have said there's no real number solution. And then one mathematician, I think it was Hamilton, it's an Irish guy, But there's a number of them at the same time. And they looked at this puzzle again. They returned to it. And instead of just saying there's no answer, they went and said, maybe there's a new number in the universe that we haven't found yet. And this number is equal to the square root of -1. And the square root of -1 is quite ugly to write. So I'm just going to call it I for short. You know, like pi is 3.14, and you know, if you've ever seen E, it's 2.712, and they called it I. And this is a new number. And this is our first complex number. Now, it's not a real number. It's not like 42 or -7, right? It's not in a number line. You can't measure something and it's I units long. It's not that kind of number. It's a mathematical idea. It's a number in a mathematical sense, right? That means if I can show you a way to add, subtract, multiply, and divide these things that are called complex numbers, right? If I can show you a way to do that, then the mathematician will say it's a number, and we'll call them complex numbers. So what they did is they created a number system called the complex numbers. And they have this format. They are A plus B I, where I is just short for the square root of -1, and where A and B are real numbers. So to give an example of some complex numbers, 3 plus 2i is a complex number. 1/2 minus I is a complex number. 1.3 plus 10i is a complex number. Do you see that they're just made up of a real bit plus an imaginary bit? And that's actually what these are called. This number here, this real number A, is called the real part. And this guy here, B, is called the imaginary part. Now, if you feel, yeah, this doesn't look right, you're not alone. See, when this was first introduced into the mathematical world, there were a lot of skeptics. There were a lot of mathematicians who said, it doesn't make sense. You can't get the square root of -1. But they were blocking their ability to see further. Because what they should be saying, you can't get a real number that is the square root of -1. But there might be another different kind of number where this is true, right? Another world where these numbers can live. So far, so good. So let's show you how we can find some complex numbers. You tend to get them when someone gives you a square root of a negative number. Now, remember that the square root of -1 is called I. So the square root of -16 is basically 16 times -1. You can split that up as the square root of 16 times the square root of -1. And the square root of 16 is a number, it's 4, a real number. And that guy is called I. So what do you think the square root of -25 would get you? What would the square root of -25 get you?
5i.
5i. Right, so you're just going mathematics here, right? You're not going to try and figure out in your brain, what is this thing? Because it'll just hurt your brain. Well, it's a mathematical thing, right? Some special kind of number. Now, suppose that you wanted to find Well, that was as a complex number. Well, if I split it up, can I just jump straight to that part? Are you happy with the square root of 20i without me writing down the individual pieces? And that is kind of half right. But can't we simplify the square root of 20? We've done a lot of these guys. So simplify the square root of 20. What does that get you? We've done a lot of these guys in last week or so. Square
4
root.
and 5.
Okay, I like it. 4 times 5 with an I, and that gets you 2 square root of 5i. How about the square root of negative? I only do the same guys all the time. There we go. Negative 18. So that becomes that guy. So all you need to do now is simplify the square root of 18. Any takers on the square root of 18?
9 and 2.
You nailed it. 9 and 2. And won't that get you the 3? So 3 square root of 2i. Do you feel comfortable you can at least take these funny guys and write them down as a complex number? Even if you're not convinced that there is such a thing, can you do the process of creating them? Do you feel comfortable with that? Okay, let's try it. I want you to find what these guys are written down as complex numbers. I'm not going to give you much time. You've got 1 minute starting now. Okay. First one should be nice and easy. Right. Square root of 81i. But 81 is a good number, isn't it? It's a perfect square. So what one do you get for the square root of 81? What number is that?
9.
This one? You get 80. Well, 80 you have to do a bit of work on, don't you? How's 80 going to split? It's going to have to
4
split
and 20.
4 and 20. Can you do better than 4 and 20?
16 and 5.
16 and 5. I agree that's a bit better than 4 and 20. Bigger number. Right. So 16 and 5 gets you 4 root 5i. Now, if you'd done the 4 and 21, you could then split the 20 as a 4 and a 5, and you'd eventually get the same answer. So it's not that you're wrong, it would just take you a little bit longer. And this guy, whoops, this guy is 12. And I believe 12 is what, 4 and 3? So what does that? 2 root 3i. So at this point, if I gave you a guy that looked like this, do you feel comfortable you could write it down as a complex number, right? A guy with an I at the end. So what we're now going to tell you is, since I've said that these are numbers, doesn't that mean that I need to show you how to add them, how to subtract them, how to multiply them, and how to divide them, right? We're only going to do add, subtract, and multiply. It's not that you couldn't divide them, but dividing them is very complicated, so we just don't go there. But it can be done. So you're just going to trust me that you can divide them, right? But I will show you how to add, subtract, and multiply them. So let's look at add and subtract. So I'm going to have full complex numbers, right? With not just an I bit, but a real part. So it's very useful to put little brackets around them. So here is my first complex number, 3 plus 2i. And I want to add 7 plus 5i. Now, mathematics should be consistent and it should be logical, right? So you would hope that there's a rule for adding two complex numbers that is kind of reasonable, right? That makes sense. If you were the first person to tackle this question, how would you add these two guys together?
I would add the 3 and the 7, and then the 2i and the 5i.
And you would be exactly correct. That's exactly what you do. And these two get you 10, and these two get you 7i. Complex numbers are sometimes thought of as two-dimensional numbers. They've got two parts, but they don't play with each other. Isn't 5 plus 2i almost separate? You know, it's like adding like terms. That's an analogy that works quite well, I think. You know, adding the numbers, adding the i's. Kind of makes sense, doesn't it? Complex number. You want to add them. You add the real parts, you add the imaginary parts. Make it a little bit trickier. Not a lot trickier, but just that. Still adding. So you would go 2, add 5, minus I, add 7i. The real part becomes 7, and the imaginary part becomes 6i. Does that make sense? Okay, here's a weird one. It's still adding. I'll let you think about it. Maybe do it in your head, or you actually write it down on paper if that helps. I'll let you look at it first before I do it. Did warn you, it's a weird one. But there's nothing to this. Sarah 2, would you agree there is nothing to this? Sarah 1, did you get my hint?
They cancel?
They do, they cancel. So what you're going to get is, I guess if you're writing it down formally, it's 3 add negative 3, but that cancels out. And it's what, negative 2i add 2i, but that cancels out. And here we come with the mathematics of the world. That's 0, and that's 0. So isn't the answer just 0? You don't say it's 0i or 0, you know, without an I. Isn't something just 0? It's gone. It's disappeared. Right. So the answer to that one was nothing to it. It was just a single 0. So although you might be tempted to write that as an answer, think about it. What does 0i mean? It means you don't have any, right? Well, if you don't have any, shouldn't you just call it 0? Like if I said I had 0x, wouldn't you say, why are you calling it 0x? Just call it 0, right? Kind of like that. There's no need for you to put an I. It's not there. Okay. Are we good with add? Do they seem reasonable? Add the real bits, add the imaginary bits. Let's do a subtract then. And the brackets are helpful here. So my first complex number is 10 plus 3i, and I'm going to subtract this complex number, 4 plus 2i. Okay, if you were the first person to come across a subtraction, what would be a sensible way to do it? How could you subtract those two guys? I have a 10. What will I write next door to it?
Take away 4.
Agreed. And then I have a plus 3i. Take away 2i. Do you see 10 take away 4? 3 take away 2i? Now, 10 take away 4 is the real part, which is 6. And 3i take away 2i is 1i. Do you think in mathematics we will write it that way? No. We will write it like that. You know, we never write 1x. Don't we just write x and everybody recognizes that x on its own means you've got one of them, right? Same kind of rule, right? You don't write 1i. You don't need to write the 1. I on its own is enough to tell you that there's one of them. And that would be the answer to that. Okay, let's make negatives everywhere. Negative 3, take away 4i. Subtract negative 2, take away 6i. You try that one first. Now be careful about the double negatives. There's a lot of them floating around. Okay, here goes. Negative 3 subtract negative 2 is like adding 2. So those give me negative 1. So hopefully you got negative 1 there, right? Negative 3 subtract negative 2 is negative 3 add 2, and that gets you negative 1. The next guy is negative 4i. Subtract negative 6i is like adding 6i. And negative 4i plus a 6i gives you plus 2i. We're good with that? A lot of negatives and subtracting negatives going on. A little bit different. You try that one first. Okay, I take a volunteer. What am I going to write down first?
Would this be kind of like factoring or no?
I don't know. It depends on how you look at it. What do you want to write down as the next line, and that'll give me a clue if you're on the right track.
I would want to do 2i times negative I.
Not that. Oh, I know what you're getting at. Yeah, almost, but not. No, but I know exactly why you see that, or why it looks that way. But it isn't. It's just a subtraction. But what you were talking about does happen later on, so you will see that. But when you see it, you'll see it looks slightly different, and hopefully that'll be able to separate them. This is just that guy, take away that guy. So this is still a subtraction. So it's not a multiplication, right? So 2i, take away this. So
That just
2i,
becomes I
right? And then this guy,
minus or minus 7.
yeah. And they two give you I, and that's minus 7. Now, I don't know if this helps, doesn't help me, but it might help you, because some people see things differently. Would it help to call that 0 plus 2i and stick brackets around it? Would that be less likely for you wanting to do the multiplication when you see it like that? See how I've just called it 0 plus 2i now instead of 2i on its own? Does that help you see first guy take away second guy? It looks much more like a subtraction. Are we good with subtractions? I get nods. Nods are good, but they're only good if they're truly are. Okay, let's give you a couple of questions to try out, and we'll call add and subtract done, and then we'll look at multiplication. So pick just 3 questions. Okay, I'll give you 90 seconds. Start from now. Good boy. You sure? You sure? It's barely paying us a visit. You want some scratching. Oops, almost forgot the time. Yeah. Oh, God, I'm busy. Okay, let's get this show on the road. Adds and subtract. Sarah, do you feel brave? You want to go for the first one? I didn't even put a number on it, so one of you can speak and say it's the other one, you mean, right? Who's going for it?
Can I try?
Yeah.
I got I minus 7.
For this one?
Yeah, so I did sorry, no. Ha, I was looking at the wrong one. 5
Okay.
plus I.
Okay, agreed. So you did a 2 plus 3 and got a 5. And you do a negative I plus a 2I and you got an I, and you were correct.
Yeah, I was looking at the last one that we did.
Oh God, I haven't even looked at that one yet, but you could be right. Okay, maybe it's better just picking volunteers, because asking Sarah 1 and Sarah 2 is like watching paint dry. Come on, you two. One of you is going to go for it, right?
For number 2, I got 1 plus 10i.
You nailed it. So for those who need to see the, where it came from, it's 3 take away 2, which gets you the 1 that she said. And it's this one's a messy one. It's 5 subtract negative I, which means you add it. Yeah, that wasn't too painful. You nailed it. 1 plus 10i. Okay, we just got one last one. I'll take anybody for the last one. Who feels brave about this guy? And there's a lot of negatives in here, so it's easy to get one of them out of place and get part of it wrong. So don't be too worried if that happens. But
I got
try.
2 plus 3i.
I like your answer. So here it goes. -1. Take away -3 is add 3. So the real part gets you 2. And then we have the imaginary part, which is -2i. Subtract -5 gives you plus 5i. And these two, I believe that's what you just said. So I agree with you. It's 2 plus 3i. Okay. I'm going to spend a few minutes talking about these complex numbers, and then I think we'll have our break. Give our brain a chance to, assimilate it. And then when you come back from the break, we'll do the multiplies. These are numbers. You just got to trust that in a mathematical sense, they are numbers. Now, right now, we've shown you how to get them, right? It's square root of -16 is, for instance, how you could get one of them. And we've talked about how you can add and subtract them. And would you agree that they're consistent, right? You get one answer to add and you get one answer when you subtract. It's not like on Mondays, the answer is 1 plus I, but on Tuesday, it's 2 plus 5i, right? It's not random, weird stuff, because that wouldn't be a number then, wouldn't it? It would just be, it wouldn't have any name, right? It'd just be random, write down what you felt like. That wouldn't be very mathematical if you could do that. So it has a structure, right? You add the real parts, you add the imaginary. You subtract the real parts, you subtract imaginary. But complex numbers don't have a property that every other number that we deal with does. And that property is called size. If I gave you two numbers, and it doesn't matter if I make one of them a fraction and make the other the decimal, would you agree that one of them is typically going to be bigger than the other? Right? They have a size. I mean, if you drew a number line, 3 would go here, 4.1 would be here. That's the big one, right? And that's the small one. So if I give you two numbers, one of them's bigger than the other. Well, I guess you could get the same number, but that'd be a daft question, right? 3 and 3, right? As long as they're different, wouldn't one of them be big and the other one will be the smaller of the two? They have size. Complex numbers do not have any real size to them. Here are just two random complex numbers. That one isn't bigger or smaller than that one. Can you see that complex numbers don't have a size, right, property? Isn't that kind of weird that they don't have a property of size? So you could say, well, I've got one complex number and it uses much bigger numbers than the other. I guess you could say that, but that's not going to happen every time. Would you agree it's quite hard to tell which of these is any bigger than the other? So complex numbers don't have size. And actually, complex numbers are not the only numbers in the world. There's a whole branch in mathematics that deals with creating number systems, fields and rings. And there's matrices, for instance, can create fields and rings. So there's lots of things out there that have the property that the objects, the collection of objects, are numbers, but they don't have size. So I don't know if that's a cool thing or a bad thing, but it's an interesting thing. That the numbers you'll deal with in your real life will have a size, right? One of them is going to be bigger than the other. But when you deal with complex ideas in mathematics, numbers don't necessarily have a size. Okay, we'll give you a break. I'll see you back here about 25 to. It gives me a chance to bug somebody and ask them things because I'm nosy. So who shall I pick? Rachel, do you tell any of your family any of my jokes, and have they disowned you because of that?
I have not told a joke yet, but if you want to tell me one, I will tell my husband.
Did you do the vampire joke? Did you catch that one?
What is that one?
Oh, too long now. You're going to have to watch this video and find out what it is and tell him. I'll give you a short one to tell your husband then. Did you hear about the two guys that were talking about Switzerland? And one of them turns around to the other and says, "What's so good about Switzerland?" And his friend says, "Well, their flag's a big plus." Carla, did you just shake your head at that joke? Well, there should be a rule. You're only allowed to shake your head if you tell jokes and they're better than mine.
No, I don't have any.
Okay, you're going to tell your husband that joke, right?
I'll tell him that one, yeah.
So are either of you military? Are you ex-Navy?
Ex-Navy.
Both of you or just you?
Me and my husband.
Oh, that's quite, yeah, there's quite a lot in Bremerton that are like that. Well, at least one of you's Navy. Did you meet in the Navy? I'm just nosy.
We met 12 years ago, been married 5, and have a 3-year-old.
Oh, so when you said you met 12 years, does that mean you were together for 7, or you met and he went one way and you went the other, and then you met again?
We're together. So
together. So that's
yeah.
a big chunk of time. I know, it's cool. Well, not me personally. My wife had a friend, and she was in the Navy, and she married the guy that she is. But you had to be very careful because he was her supervisor. And so that was a really dodgy place to be because of that. So I think you have to be quite careful when you form a relationship in the Navy to make sure there's not a hierarchy thing, because it could get you into trouble. So I'm assuming that you and your husband were in different parts of the boat. I don't know how you describe it.
We were in the same part of the boat, but we were the same
Level.
So
Right.
yeah.
So there wasn't any seniority issue. Right. Yeah. I think there are good reasons for having that role, of course. You know that you shouldn't date someone in a superiority issue. It just causes trouble. So useless piece of information, when I'm in Bremerton and I meet Scottish people, and I do occasionally meet Scottish people, this is their story. It's a woman that I meet who's Scottish, and she married an American sailor, and they came to Bremerton, and now she's divorced. So that has happened quite a few times. So don't know what's up with that, but that's what it is. So I don't know any Scottish guys who are in America or Bremerton that did it the other way around, that they married a woman in the Navy and now they're over here. But you might know somebody. So who will we pick on? Sarah. Sarah number 1. Right. I don't know anything at all about you. Is there anything you want to share? Sarah too, do you want to tell us anything like you love Cliff Richard? I don't know. You get nothing for us.
I'm not that interesting.
Is there anything you want to know about me then? I'm not that interesting either. Okay, got it. Sean, do you want to know anything about me? Or do you want to share something about you that interesting is a strange word. Lots of things are interesting to me.
What's your favorite color?
Blue, because that's my football team. My football team is blue. So that was an easy one. I'll show you. I don't know if I can show you this, but I'll try. Just passing time while we. I think it's this one. There we go. Come on. There we go. Yeah. And how close I can get. And I don't know if it'll focus. Probably won't. There. It might. This is obviously my wedding ring. Can you see a hand or two hands holding a heart? Can you see that? That's a quite old Celtic symbol. It's called a Claddagh. Obviously, it has, since we're married, it's the joining together of our hearts. It's kind of cool. And since we're talking about football teams, this ring, excuse the dirt, I was fixing my car and I didn't have time to get ready. So if you look at that really, really carefully, can you see some letters of the alphabet in it? Right. The R is for Rangers. There's an F and a C. So it's Rangers Football Club. So when you said what's my favorite color, that's the team, right? This particular ring belonged to my dad, so I can inherited it. And probably in America, but definitely where I come from, the football team you support is inherited. So my grandfather was Rangers support, and his father was Rangers, and my father was Rangers. And if I had children, which I don't, unfortunately, those children would have supported Rangers, even although we're in America. So let's see, who can we best? Sean, do you like sports?
Yeah.
Would
Some
you
sports. I watch a lot of hockey.
Oh God, isn't hockey just violence organized in the form of a? They just give them weapons and armor, and occasionally they hit this little.
It's like strategic violence.
There's a reason behind their violence.
Yeah.
So to get into hockey, I'm assuming you're talking ice hockey, because there's a hockey that we play in Scotland which you do outside on the grass.
Yeah, ice hockey.
Right. Have you ever seen the hockey that you do on a field with grass?
Field hockey, yeah.
Yes.
Yeah.
That is worse than ice hockey, because in
it's
ice
crazy.
hockey you are armored up on ice hockey. But see, when you play, because I played it in school, and I don't know how many black and blue shins I got, because they wallop that stick and you were getting hit.
It's like a rugby with sticks.
Yes, and rugby is bad enough. In our school, we played rugby, and we played hockey, and we played football. And out of those three, soccer as you would call it, out of those three, soccer was by far the safest. I mean, rugby is contact. It's like American football, but without protection.
Yeah, it's awesome.
It is. Oh God, that's a miracle. I never broke anything. And hockey with that stick. Now, you know, I've only got one good eye, so I was actually more dangerous than anybody, because I wouldn't be trying to hit the other person, but because my depth perception is so bad, I very often did. You know, I thought I was trying to hit the ball, and you know, somebody's shin bone would get cracked. Painful, very painful. Is that the only sport you like?
It's the only one I've been watching recently.
Where'd you get that from? I mean, that tends to be a northern state. along the Canadian border kind of sport, isn't it?
Yeah,
Well, I
it's
guess
weird.
Washington is.
They're getting a hockey team for next season.
I did hear about that. My wife left hockey because she spent her formative years in Alaska, and she lived where she lived. You could only get Canadian TV, and so she got a lot of hockey, and then got quite into hockey because of that.
Yeah, when I I was in the army for a while, and when we did our swearing in before you left for training, I got to swear in on the Los Angeles Kings ice during a hockey game, which was pretty cool.
Oh, that does sound cool. That's one of those kind of memories you can take with you. That's
Yeah,
kind
it was
of cool.
wild.
So, have you ever been to any of the ceremonies when you were in the military, where you got to take part in some kind of show as a military person?
Yeah, a few.
Are they not that interesting then?
It's not so interesting when you're standing there, no.
Uh, so, are you under instructions not to cheer if your team wins or anything?
No, I mean when you're just taking part in the ceremony, it's pretty boring.
Okay. Well, I know a little bit about Jamie Lynn. Jamie Lynn, for instance, likes computer games that are Asian in theme. Is that a good way of saying it?
Sure, yeah.
Right. So when you play them, are they games you like to play? Are they the ones where you end up killing people, or are the
I
ones
like
where
to
it's puzzles?
play multiplayer online, killing others.
So you do go around killing people you've never met in real life.
Yeah.
Okay. As long as you don't do it in real life, it's totally okay. Rachel, was that you were telling your husband that joke about Switzerland?
I was getting my dog. Did I ever show him to you? Or show her
I
to
don't
you?
know. Show us. Go get your dog. Oh God, look at that face. Oh, I think you'd call that a German Shepherd. Is that right?
So she's a German Shepherd Rottweiler mix.
Oh, okay. Back home, we didn't call them German Shepherds. Back home, we called them Alsatians. It's just a name for them. I think because the part of Europe that they came from was a place called Alsatia, or whatever. And so just a different name. True story about my sister Mary. She comes over and visits until COVID came. But she's got a very, very strong Scottish accent. So if you think my accent, which I don't have, is bad, you would probably need subtitles if my sister was speaking. Anyway, she was out with the dog, taking a little walk, and one of the neighbours came over and she was talking. She was trying to talk to my sister, but it wasn't working. Just she couldn't understand what my sister was saying, and we discovered 2 weeks later that the woman that she was talking to was speaking to my wife, and she was saying, I met one of your relatives or someone. She was walking the dog, and she said, what part of Russia did you come from? She thought she was Russian. Now, I don't know. I've been accused of being Irish occasionally. I can just about understand Irish. I was accused of being Australian and New Zealand. That one's pushing it. And once I was accused of being German, but the person was drunk at the time, so I'll let that one slide. Right? There is no way I sound even vaguely German, right? In fact, do any of you really hear me as an accent anymore? Or do you just hear that I talk funny? And that's about it. Or do you even hear me as an accent anymore, if any kind?
No, I get used to accents pretty quickly.
So it's just the way I talk now.
Yeah.
Alyssa, you're going wobble like, yeah, there's still something going on there.
Yeah, kind of.
Yeah. Well,
It's more of
It's-
like if I think about it, then I'm like, yeah, you have an accent, but generally it doesn't really register.
Did it, what you're allowed to say this, did it worry you when you first heard me talk because you thought, oh God, math is bad enough and now I have to try and figure out what you say? No. So it
Something
was,
that-
you had that kind of worry at the beginning. Do you still have that worry?
No, not at all. I'm used
Okay.
to it now.
I can understand that. I would agree. I've had some professors at university who weren't Scottish or English, and they've been, yeah, that could be a challenge at times.
all my friends say, or like people who meet me, they're
Uh-huh.
like, "Oh, Jamie, do you have a second language?" And it's like, "No," or like they'll say it's English your first language, and it's like, "Yeah," because I'm so bad at speaking it because I have like some speech impediment. So then
Oh.
they think like, "Oh, are you like from here?" It's like, "Yeah, I'm from here."
See, the next time they do that, hit them with something. They'll stop doing it.
Oh, I got used to it, but then
Just throw some at them.
but then
Cheeky buggers.
ever since I learned like Japanese from my high school, I kind of mix. Once you learn it, you can't unsee it because their vocabulary of like pronouncing certain words messes up my English vocabulary.
Oh God, you poor
'Cause, like,
thing.
I do the same thing.
Yeah. So I'm here
What-
like,
oh,
oh
yeah.
God.
What language did you learn that kind of screwed up your way of speaking, Lexi?
Also Japanese, but
Oh,
I live with Spanish speakers.
And I also like live with a lot of people. My family's like Filipino, so they speak Tagalog. So I'm around with a lot of Tagalog speakers, and they also speak different dialects. So I can like understand it, but I can't really speak it.
A lot of
oh,
people.
you are multilingual in a lot of ways. You may not be able to speak more than one language, but you can at least understand more than one language, which is a lot better than me. So, good on you.
People do the same with me, where they think I'm from somewhere else, and that because I get nervous talking to other people, so I'll like take a bit. They'll think I'm from another country, and they're like, "Oh, can you understand?" And it's like, "Yes, I can understand you."
Do they
People can't
mention what
understand
country?
me.
Do they think you're from Europe or
They
what?
think they tend to think I'm either Mexican or Turkish, which is one I get a lot.
I think sometimes that mix up can happen when you grow up in a multilingual household. So I think that's just pretty normal.
Yeah. Well, America's a cool place. I think multilingual and multicultural is really cool. Right, so I promised you multiplication, but not division, so I'm going to do that. But before I do that, I have to kind of give you a little background of some information that you're going to use. Now, let's return to our friend, the square root of -1, right? The guy we call I. And you are going to do I squared occasionally. Now, if I write down what I squared is, it's obviously I times I, right? That's still true. And I is the square root of -1. And that guy is the square root of -1. And now I'm going to do the answer. And the answer is -1. If you take the square root of A and you multiply it by the square root of A, isn't the answer just A? Right? Square root of 7 times square root of 7, the answer is 7, right? Square root of 20 times square root of 20, the answer is 20. Square root of I times square root of I, right? Square root of -1, I should say, times, it's a times symbol, square root of -1 is -1. So that is very important that you remember that when you do multiplications, if you get an I squared, I'm sticking lots of arrows around it so you'll focus in on it, you will know that that is worth the real number -1. So I'm now going to use that and start multiplying. So here's 3 times 2 plus 5i. That is actually a distributive law. So we won't need to worry about that because it's not going to happen in this question. According to the distributive law, don't you go 3 times 2 plus 3 times 5i? And 3 times 2 is 6, and 3 times 5i is 15i. No, that wasn't too hard. I mean, technically, haven't I multiplied? I know I've only multiplied by 3, but I've multiplied. It make it a bit harder. Let's suppose I do 2i, 1 plus 4i. So it's still a distributive law. So it's 2i times 1 plus 2i times 4i. Now 2i times 1 is just 2i. 2i times 4i is plus 8i squared. Hey guys, there's an I squared here. See it? Which means that we change it into -1. Remember, anytime you see an I squared, it's worth -1. Right? It's weird. That's what kind of makes a complex number weird, right? It's the square root of -1. So when you square it, you get -1. Now that ends up being 2i take away 8, or -8 plus 2i. Are you happy that those are the same thing, just written in different orders? Okay, let's try another one of those guys. Let's do -4i, 3 minus 2i. So it's a distributive law again. -4i times 3 minus 2i. So you're going to get -4i times 3. So -4i times 3. Then you're going to have -4i times -2i. Okay, these two guys get you -12i. This is a bit messy. -4i, I guess I should put a bracket there, times -2i is plus 8i squared. Are you okay with -4i times -2i is positive 8i squared? Is there anything there that can be changed, replaced? Anything here that can be changed or replaced?
The I squared,
What am I going to change it to?
-1.
So won't that be 8 lots of -1, so -8 when you're finished? Do you see how that you can multiply two complex numbers together, at least in the distributive law way? How about this fella? This is like the ultimate multiplication, right? First time anybody's done this, pretend it's the first time. What method do you think I'm going to use to multiply this guy by that guy?
Foil.
I like it. You agree? Foil. Change palette colors. The F of foil is 3 times 5, which is 15. The O, the outside of foil, is a 3 times a 6i, which gets you 18i. The inside of foil is 2i times 5, and 2i times 5 gets you 10i. And to finish, the L, the last of foil, is 2i, positive 2i, times positive 6i, which gives me positive 12i squared. Isn't that very like a normal I know, 3 plus 2x, 5 plus 6x kind of look, right? Isn't it kind of the same kind of look to it? Now, tidying up is about to happen. Collecting like terms is very useful, but something else is also going to happen. These two guys in the middle can be combined to get you 28i. Can you see I have a 12i squared? What number will 12i squared become?
-12.
And that means that I can now combine these two guys and get 3 plus 28i. Haven't we got a method now for multiplying two complex numbers together? And isn't the answer just another complex number? Right? We can add them, and that works. We can subtract them, that works. We are looking at multiplying, and that seems to work. You'll just have to assume that division works, which it does. So it's a number. It's a complex number. Complex is just the name we give to them. Okay, I'll let you try this one. You try that one first, and then I'll do it. Okay, who's going for it? Take a volunteer. Anybody feel up to doing the F, the O, the I, and the L in this question?
Eight
Okay.
plus
Sorry,
4i.
right, rewind because I didn't quite catch the first one again.
8.
So 2 times 4
Uh-huh.
is 2 times 4. We're multiplying.
8.
Okay, right, didn't catch that. Right, what's the O going to be then?
4i.
The I, which is these two guys, -5i and 4.
20i.
Yeah, with the negative, I'm assuming.
-20i.
Agreed.
Minus 10i squared.
Yeah. I'll do the middle bit because that's the easy part. I want to make my life easy. Be careful about -10i squared. You know it's going to be a number, right? Because I squared turns into -1. But you have to be careful about is it a plus or a minus, right? So what's -10i squared going to get you when you're finished?
Plus 10.
Agreed.
10i
Yeah.
squared.
Well, not an I, just plus 10.
10.
Right? Because I squared gets you -1 and -10, lots of -1 together, that's a plus 10, which means that we have an 18 take away a 6i. Look at this one. Oh, I won't put my arrows in, it's too quick. If you go 2i times 2i, right, you get 4i squared. 2i times -3 is -6i. 3 and 2 gets you plus 6i. And 3 and -3 gets you -9. So 4i squared, -6i, plus a 6i, take away a 9. Those two guys actually kill each other off, don't they? -6i and +6i get you nothing. Okay. What does 4i squared get you?
-4.
-4.
Great. And the other guy's still there. So can you see that you can sometimes get an answer that two complex numbers multiplied together just give you a good old-fashioned normal real number? But that's okay. That is not a contradiction. Technically speaking, if I wanted to write it down as a complex number, couldn't I call it -13 plus 0i? I mean, I wouldn't, but technically I could. So it still qualifies. In fact, do you know all real numbers? They're just complex numbers with no I part to them. Right, so 42 is just a complex number. It's just 42 plus 0 i's. So what that means is that complex numbers are actually even bigger, right? There's more of them than the real numbers. The real numbers are just like a special case of complex numbers, but they don't have an I. Do we feel good about multiplication? Feeling good? Right. I'm going to give you a couple of these guys, just two to try out, and then we'll show you the last bit of multiplication. And we are done with that part of the world. Then I've got something else to show you. Oh. Okay, there's two guys. Couple of minutes. Go for it. in the last few seconds. Okay, if you do the F, 3i times 4i gets you 12i squared. The O is 3i times -1, which is -3i. This is 2 times 4i, which is positive 5i, and 2 times -1, which is -2. This fella gets you -12. The two guys in the middle combine to give you positive 5i. And so you end up with -14 plus 5i. Did you get that one? -14 plus 5i. Okay, I got one nod. Okay. The first 2 times -3 is -6. 2 times -2i is -4i. -3i times the number -3 is a positive 9i. And -3i times -2i gets you plus 6i squared. So I get a -6. These two guys combine to give you positive 5i, and this guy is -6. So we get -12 plus 5i. We're good on the second one. Right, got a couple of nods, that's good. Well, we're pretty much, but not quite, we're pretty much finished this section. But there are a few special situations that we need to deal with because they do crop up. I'm looking at one right now. And this one is question 26 from the homework. And what's the difference? Some of the numbers are going to be square roots. Right, that's basically the added little twist, right? Some of the numbers are going to be square roots. Now, I'm not going to change anything else. I'm going to deal with it the same way. I'm just going to be careful. There's my F. 3 times 2 is 6. That wasn't a big deal. This is the O. 3 times -√2i. You don't really get that much out of this except -3 √2i. You see, you can't really multiply square roots in numbers. So you don't get negative square root of 6 or anything, right? That's not what you get. You just get a 3, a negative, and a square root of 2i. And if you do the inside, you got a kind of similar situation. You get a 2 and a √2i. That gets you 2 √2i. Then if you do the last guy, you get, that's interesting, √2i times -√2i. I'm going to write that down separate. Positive √2i multiplied by negative the square root of 2i. Okay, is that multiplication going to be a positive or a negative thing right now? Positive or negative? What will we get?
I think it's gonna be oh wait, never mind.
I think you were going to say, I think it's going to be negative.
I would have said negative.
Good, 'cause
Yeah,
it
I
is.
was gonna say that.
Yeah, you're right. Your first thought was the best thought. Now, what about the square root of 2 times the square root of 2? That's a number, right? None weird about that. You just have to know what the number is.
That just becomes 2.
Yeah. And won't the I and the I get you an I squared? So what you end up with is -2i squared. Agreed? So when you take this guy and you multiply it by this guy, it ends up being -2i squared. So -2i squared. Okay, these two guys in the middle, you are allowed to combine these. -3 √2, add positive 2 root 2. So if you have negative 3 root 2i and you add 2 root 2i, don't you end up with negative 1 square root of 2i? Are you happy about that? Negative 2, negative square root of 2. Right, negative 3 add 2, you're left with negative 1 square root of 2. Aye. We cool with that, guy? Okay, that's 6. What on earth is this guy going to give us? Because he is a number.
2. Positive 2.
Correct. Well done. Yes. Are you okay with that? Because why that's positive 2? Isn't that negative 1, but negative 2, negative 1s give you plus 2. So the real gets you 8, and you've got this little guy left over, and that is the final. Stick a fork in it. It is done. Let's do one more of these guys. This is similar to question 27. And it's 5 plus the square root of 3i. And it's a 2 take away the square root of 3i. Okay, there's first. 5 times 2. Oh, that was easy. 10. The O. 5 times negative root 3i. Well, if you multiply 5 and this together, all you really get is negative 5 root 3i. Right, that's it. And if you do the inside one, which is this guy, very similar to that question, it's root 3i times 2. You multiply them together, you just get 2 root 3i. It's a bit like, you know, x times y gets you xy. You know, and 2x times 3y gets you 6xy, right? You don't really combine much. You just kind of put them together. They don't really change that much. Right, the guy at the end is the killer again. I think that guy's the worst one, the L. Root 3i times negative root 3i. What will that get you? I don't need to know the final answer. I just need to know the kind of halfway towards it.
3.
Good. Positive or negative?
Negative.
Yep. And to finish, I squared.
I squared, but then that
Yeah.
goes away, right?
But that's going to go away. These two guys combine to give you negative 3 root 3i. And just like you said, isn't this guy going to go away in a minute? I squared is going to be replaced by negative 1. So won't negative 3 lots of negative 1 become plus 3? You happy with that, guy? Negative 3i squared is plus 3. Right, put the numbers together, you get 13. That's pretty much the finish. There's your answer. So there's only one situation that we haven't covered, and that's us done. This is version 28. And that is, how do you simplify that? How do you express that as a single complex number? It's 4 plus 3i all squared. And let's pretend that we're the first person to come across this question. We're trying to figure out what we need to do to solve it. Right, help us out here. What do you think the next line of working is going to look like? I'm not expecting an answer. I think
You
that's far too
square
early.
each number in the
I-
brackets.
I understand exactly why you would want to do that, but that's a little bit too early. So let's wind back a little bit instead and do something a little bit less final than that. Is there another way you could write this?
Can you boil it?
Yeah, but to FOIL it, I need to write it down, and I need to write it down as 4 plus 3i times 4 plus 3i. So that's what I was kind of getting at. Do you see that you need to write it like that so you can FOIL it, so you can get the answer, right? So it's a kind of, you have to do A before you can do B and C. So the first thing, write down your square as 4 plus 3i or whatever it is times itself. Now, if you do this guy, F O I and L. 4 times 4 is 16. 4 times 3i is 12i. 3i times 4 is 12i. And 3i times 3i is plus 9i squared. I mean, isn't it just very, very similar to what we just did, right? It's just a FOIL question. Now, we can make this a little bit better, can't we? A little bit prettier. Any suggestions for what I could do to make it a little bit nicer?
Combine the two middle numbers.
Okay, let's
16
do that.
plus 24i.
Okay, so I've got, I think you said 16. What about this guy?
9
What kind of
Negative
nine?
9.
positive. Oh, negative 9?
Negative or
So it's up-
positive?
Negative.
Negative it is. Now you put that together and I believe you get 7 with the 24i. And that would be the question of finish, right?
It was always going to be the opposite sign of what is showing.
Oh, you mean here?
Yes, that last section.
Yes.
Okay.
Yeah, that's an interesting pattern, but yes. That's so if it's a plus 9i squared, you know the answer is going to be negative. And if
Negative
it's
9.
a negative 9i squared, you know the answer is going to be positive. And the reason for that is that the I squared is a negative 1. So it introduces another negative to it. So that basically changes pluses to minus and minuses to plus. So that's the reason why that rule works. But yeah, if it's a positive thing, you know it's going to be negative answer. If it's a negative number here, you know it's going to be a positive answer. Right, well, this is the last question, so I'm going to let you lot try it first. It's that guy. And I'll just set it up as a FOIL because that's really how you do it. Okay, give you a couple of minutes. Try that, fella. Last few seconds. Hopefully, the more of these that you do, the kind of more comfortable you get with the process. Right. So There it goes. Oh, wait a minute. Anybody want to volunteer it? It's a lot in it. Hopefully you'll get it all right, but have a shot.
I can do it.
Go for it.
So 3 and 3 would make it 9. And then minus 6i, minus 6i, and plus 4i squared.
Can't fault that. Agreed.
And then it'd be 9 minus 12i minus 4.
Agreed.
And then it'd be 5 minus 12i.
And you nailed it. It's done. Now, I'm not doing it because I think we've covered enough for today, but couldn't you stick a square root of 3 here or a square root of 5 there, just make the numbers a bit uglier to deal with? But it won't change much apart from that. That's pretty much everything you could do to it. So what I want to show you now, if I can find it without too much trouble, click on this. It'll take me a few minutes to get where I'm going. Okay, I'll move that over here. I'll go to student view. Where are you, student view? There you are. Okay, there is something. Oh, hi Sarah, she's saying hello. I don't know if that means you just arrived. You will be saying hi in a few minutes, but don't leave quite yet or you'll miss a very good opportunity. You should be looking right now at our Canvas, our WebAssign homework page. You might have noticed that there's a new guy in town. This is an option. You do not need to do this. And if you don't do it, it won't make your grade any worse. Right? It can't harm your grade if you don't do it. But if you choose to do it, it will give you 2% added on to your grade. So if your grade right now is, I don't know, 82, it would now be 84, right? And if it's 73, which is not a pass, it would be 75, which is a 2.0 and is a pass. So I would strongly suggest that you do this particular extra credit work. Now let's kick in and see what you're going to be doing. I noticed that when I was doing the midterm, that one of the problems is that you weren't factoring correctly, right? So some of you need more practice at factoring. And that's what is all about. Don't worry about the way they phrase the sentence. It doesn't matter. Every single question is the same. You are going to factor it. Now, some of them you can probably do in your head, like that one. Right. Just out of curiosity, anybody want to have a go at factoring y squared plus 9y plus 8? What two numbers multiply together give you 8, but when you add them, you get 9. And don't overthink it.
8 and 1.
Okay. Y plus 8. Y plus 1. Submit answer. You better put a tick on that. Yay, I got a question right. So can you see that that's all you're going to do, right? So when I go in, then you will get a maximum of 2%, depends on how many of these you get correct. If you get half of them correct, at least that's an extra 1%. Now, suppose, and it is going to happen, that you get a guy like question, and I'll make this the last thing that I do today in any way, like factoring 5z squared plus 7z, take away 6. And let's show you what that guy looks like. Isn't this guy going to be one of those? Yeah, we're back to that guy again. No matter how many times we do it, you can always do some more, right? The more, the better. Now, to get the two numbers that are top and bottom, we do very specific things. Agreed?
Multiply the 5 and the negative 6.
Okay, so I'll put that at the top, which is negative 30. And what number goes on the bottom?
The 5? The negative 7, or the positive 7.
Correct. So far, so good. Right, now, to remind you how this method works, don't we now need to look at two numbers that multiply together that give me negative 13, but when you add them, you get 7. Agreed? Two numbers that multiply together give you negative 13, but when you add them, you get 7. And since it's a negative 13, doesn't that guarantee one of them's plus and the other's negative, right? So go hunting for the combination that does 30, because one of them's the right one and only one is the right one.
And a negative 3.
I hear you. Oops, almost put it in the wrong place there. 10 and negative 3. Double check that. If you multiply 10 and negative 3 together, does it give you the top guy? Yep. If you add 10 and negative 3 together, does it give you the bottom guy? Check. You know the way I do this is I end up drawing another one of these guys. And I put in these two numbers. So we're about halfway through. We're getting there. What do I do now? What do I do to these two numbers? Next.
Divide by 5.
Right, you divide by that guy, which is 5. And if you can't do anything, it's finished. But if you can do something, do you see how this guy can simplify? 10 and 5. You should always simplify. So how about plus 2 over 1? So these are the two guys that are going to give me my answer. So do some little brackets. And let's see how we can use this fraction looking thing to give me that factor and this fraction thing to give me that factor. Right, take this fraction. There's a negative
minus 3.
Yeah, in this case there's z, so 5z minus 3, agreed. And don't use this guy, use this guy. So what does the 1 and the 2 get me?
1 x plus 2.
Well, yeah, 1z plus 2, but it would be 1x if it was
1z.
x's, right? But that's not really a big deal. Right, can you see the technique now, right? Now, it's quite a lot going on in this technique, but, you know, if you start getting rusty, because I think some of you right now are getting a little bit rusty, you see that you would get stuck on the factoring. And factoring is not going away because we are going to be doing later quadratics.